CBT Nuggets JNCIA series Firewall filters. All right, we're going to be continuing really our deployment labs as we look at really a security feature. And of course, this is covered in much greater detail in the Juniper security series, but we're going to need to go in and use firewall filters right off the bat to secure our routers, the control plane of our particular router. So in this nugget, we're going to look at kind of firewall filters in a nutshell. We'll kind of break down what we can do with them. We'll look at the syntax, and the good news is there's a lot of similarity here with firewall filters and routing policies. So you've already kind of pre-learned a lot of the information to implement firewall filters. We'll look at a couple of configuration examples, like a cooking show where we actually get to see the result of our recipe before we actually start building. So what we'll do is we'll look at some examples, syntax, configuration output, then we'll go in and do our deployment lab, which is reducing the router attack surface on my 2350. Sound good? Okay, let's hit it. Okay, let's get kind of a nutshell here, a view of firewall filters. And there's really good news because you've already really learned the structure of firewall filters in our nuggets on routing policy. There's a lot of similarities. Also, firewall filters are not really heavily covered on the JNCIA exam because it's really kind of a security feature and you would dig into them much deeper on the security track. However, they are important just from a fundamental standpoint because you want to protect the data plane and the control plane to a certain extent, as in traffic going to the actual device when you get into Nugget Lab. Okay, now let's just talk about some of the similarities as we compare firewall filters to routing policies. As we're going to see here, both of them use from to match and then as the action. So they use the from keyword, which is kind of an if statement, and then the then keyword, which is really our action. Now, there are some differences though. As you know, the routing policy is going to match on route attributes, right? But a firewall filter matches on packet fields, okay? So the metadata, the fields in the TCP header and the UDP header and the IP header, that's what we're matching on. And if you've ever dealt with a Cisco extended access control list, an extended ACL, where you can match on the source address and the destination address and ports and IP protocol numbers and that type of thing, well then this is really very similar. Okay, that's one of the best comparisons, and all of the vendors have some type of firewall filter / access control list capability for static packet filtering. But a firewall filter is going to match on these packet fields, okay? We also learned in the routing policy that the default action that's taken, or the default policy, depends upon the routing protocol, okay? RIP version 2 has a different default policy than BGP, which has a different default policy than OSPF and ISIS, right? Well, on a firewall filter, the default action is to discard. And we'll look at the kind of the flow here in a minute. But this is what we would call an implicit deny at the end. So if there is no match in one of our from then statements, then the bottom line is we're just going to discard the packet. Also, in our routing policies, we applied those policies to routing protocols or routing tables, okay? But here, firewall filters are applied to interfaces, okay? Now, both of them, if there is no from statement, you're going to match all, right? So if there's no classifier, no identifier, no if in the from statement, then you're going to match all. Both of them allow chains, okay? You can chain together different filters. However, a major difference is this. In the routing policy, we didn't have to name our terms, okay? We could be just term 1, whatever. But here, we have to name our terms in our firewall filter. And it's usually a pretty good idea anyway. Now, you can still say, term _1 or term A, but you have to give it some kind of name. So we have a similar structure to our route policy. We've determined that, and we'll see that here in greater detail. Firewall filters are going to be applied to, for the most part, data plane traffic and also the control plane, or traffic that's destined to the actual router itself, like telnet traffic, for example. These are comparable to access control list in Cisco, but you can also go beyond the static packet filtering to do stateful filtering. In other words, we're actually looking at the state of the TCP connection or the UDP flow, and we can do policing of traffic as well. Now, a firewall filter is going to examine or it's going to investigate and process each packet independently. And that's the stateless nature of firewall filter. And that can be a determinant about how we build our actual firewall filter syntax, because the system is not going to keep state information on TCP connections by default. So you're going to have to explicitly allow the traffic coming through your router in both directions. Now, a stateful firewall filter, basically, if this is our internal host and this is an internet server with a stateful filter, all we have to really allow is the initial connection or initial setup of the interior host, and then the traffic coming back will be allowed by default because you have inspection going on. You have a stateful entry in a state table. We can also use firewall filters to perform counting, to determine the number of UDP one-way packets, or how many TCP connections we have, or how many embryonic unfinished three-way handshakes do we have. We can also use these to monitor our environment as well. And as I kind of alluded to, we have a lot of familiarity here with our routing policy because we're going to use terms, named terms, and then the from statement to identify or classify traffic, like an if, and then we have the then, which is our action. Let's go ahead and borrow this diagram from our routing policy because firewall filters have a lot of similarities. Let me just jot that down up here, firewall filters. Now, as you can see in our firewall filter here, we have three terms, and you don't have to have three terms, by the way. We could just have one term, one thing we're going to filter on. But we have term 1, it's named 1, 2, and 3. Now, even though we have a common structure here, remember, routing policies and firewall filters do have different purposes. They also have different criteria for matching and different actions that are going to be taken. Now, our fundamental component here is the term, just like in a routing policy. And a term can have 0 match conditions, which is basically match all, or it could have 1 match condition, which is basically the one from statement. Again, we don't have to have a from statement, but if you don't, it's going to be match all. In other words, all traffic will match the firewall filter term, and it'll be subject to whatever action is stated with our then statement. And of course, we can group these things together, and the order is very important. So if you have term 1, 2, and 3, and you actually want this particular condition to be tested second, we'd have to insert this one right here. And you can do that with the insert command. So we evaluate with the from statement, which is basically from something, So is it an address, an IP address, an IPv4 address? Is it some numerical range of a port number? Is it some bit field in the TCP header or the IP header, right? We're classifying it on something. If there's a match, then we will take the action with the then statement and we'll stop there, If it's a terminating action, right? We do have terminating actions here as well. But if we match on a terminating action, we're just going to, here's a check mark, we're going to stop. If there's no match, we're going to move on then to the next term if one exists. And then we'll test with the from statement. If there's a match, then we'll do something. If it's terminating action, we'll stop there. If there's no match, we'll move on to the next term if one exists. Now, what if one doesn't exist? Well, there's an explicit discard at the end. So if you do not match one of these terms in the firewall filter, the default action is to discard. And that's a lot different than we saw in our routing policy, which can have different default actions. So if we get to the third term and we evaluate it with the from statement, and if there is no match, then we're going to discard that packet. If there is a match, of course, we'll take action. Now, we designate the criteria that we're going to use to match packets with the from statement. the from statement in the firewall filter term that we just saw. And we can use a lot of the different header fields in these protocols as our match criteria. But keep in mind that all of the header fields aren't necessarily going to be available to us because it depends upon the way that we process our firewall filter. So if you specify a certain header field, the Junos will look for a match at that location in the header where it expects that field to exist. But it doesn't check to make sure that the header field makes sense in the particular context we're in. So, for instance, if you designate that the software should look for the ACK flag in the TCP header, the software will typically look for that bit to be set at the proper location in the TCP header. But it doesn't check to actually see if it was a TCP packet. So you need to set this up so that Junos checks that the packet is a TCP packet and was the TCP ACK flag set or flipped from 0 to 1. So the things that we're going to match on would be the address, the IPv4 address, the source address, the destination address. Okay? We can also look for particular TCP protocols, okay? A numeric range of port numbers, either a single port number like 23 or 161 UDP, both source and destination, and we can also look for bit fields. For example, is the ACK flag turned on, okay, from 0 to 1? Is the SYN flag 0 to 1? The urgent flag, things like that. Now, that brings up some other reference information we need to be aware of. Now, one thing you're going to want to do in the future, this is kind of what I would call a perpetual homework assignment, is to be able to go and kind of get a handle on the different metadata that's in the different headers. Like here's the TCP header, here's the IP header down here, right there, and this is the UDP header right here. And obviously the thinnest header is obviously UDP, which only has the source address and destination address and then protocol and length. So there's not a whole lot of metadata that we can match on in the UDP header. But the TCP header, of course, source port, destination port, we've got these flags that are here, we've got some options. So in IP, of course, IP address, source, destination, there's options, there's the protocol field, type of service. So on an ongoing basis, you want to familiarize yourself. So go up to, I don't know, Wikipedia or some other source on the internet using your favorite search engine and start learning about the metadata that's stored in these three headers specifically. And something else that will also help you is to go as a homework assignment and go look at the different ICMP message types that can be in the ICMP header, because those message types, and there's a bunch of them, we can also filter on those to only allow certain types of ICMP traffic. So that's probably 4 good categories for you there. Let's move on to the different actions that we can take, right, with the then statement. So, we're basically saying then we're going to do some of these things. Now, our terminating actions, so if we hit one of these, we're just going to stop processing our firewall filter, right? If we see an accept, or if there's an action of discard or an action of reject, we know that by default, if none of the terms find a match, then the default action is to discard in a firewall filter. We've already established that, and of course that's a terminating action, so that's going to pretty much end that firewall filter processing. We can do flow control with the next term statement. So if something matches, then we'll just go directly to the next term. This is where we start to separate ourselves in the firewall filtering syntax from the routing policy. For example, look at these modifiers. We can do things like count. Like I said, we can count a certain number of connections, or we can count a certain number of packets. We can log information. We can send information to a syslog server. And we also have some other modifiers that we're going to talk more about. We can do forwarding class as a modifier, loss priority as a modifier, and then in this particular nugget we'll look at the policer modifier, which is also going to be covered on the JNCIA exam. So there's our match criteria and actions. Again, the match criteria, basically the from statement, and the action criteria, the then statement. Okay, before we go in and start configuring firewall filters, let's look at the end result, which is really a great way to do it. We kind of know where we're going with our scenario. So let's say we've got this network here, this corporate LAN. It's on 172.30.102.0/24 behind this Juniper router. Let's say it's a 2320. Then the network that connects to the internet or the service provider is the 209.165.200.0/30 network. We'd have probably .1 here and .2 over here. Now, what are we going to do? First of all, we're going to create a firewall filter. So you would go to the Edit Firewall hierarchy, and you would say Edit Firewall Family INET Filter, and then give it a name. So we're going to call this one Nugget Out, right? So we're going to deny IP spoofing attacks from our inside hosts here, because this is obviously Nugget Out, and we're going to apply both of these firewall filters on this outside interface here, which is most likely 200.1, right? So what we're really doing with this particular firewall filter is making sure that our inside hosts are good netizens, right? So what we're saying is we want to deny them doing any spoofing. So our match condition is to say if it's a source address from 0.0.0.0, which really is not a good source address. That's okay for a destination address. But if it's a source address of any, and if it's any other address except for the 172.30.102.0/24 network, then we're going to log it and we're going to discard it. Okay, so basically what we're doing is we really only want packets sourced from this network. So that's our first term. Our second term is going to be evaluated, and of course if there's a match up here, discard is a terminating action, so we'll just stop processing the Nugget Out firewall filter. But if this doesn't match, then we'll look at the next term, which is called Except Else. Okay, so the condition here is to count, and we're going to create a counter. Obviously, if our packet gets to this second term, it's on this network, right? 172.30.102.0. So we want to go here, and we have a counter named outbound-accepted. So we created this name here. Okay, so what you follow with the count command is the name of your counter. What are we doing in the counter? We want to count the accepted packets to get through there. So we see a combination here of being able to log and discard certain packets that are being spoofed from the inside, and we're also going to count legal packets that are from the 102.0/24 network, because that's our exception, and we want to count the accepted packets. So this is our output filter, and we're going to assign this to this interface right here, which is something like, let's say, gig E001.0, for example. Okay, let's look at now our input filter. The input filter is also going to be applied to this same interface for basically traffic coming from the internet to our corporate LAN. Okay, here's a firewall filter that's going to be applied on an input, okay, on this interface, and we're going to name this one Nugget In. We're also going to deny spoofing, but we're going to deny spoofing or masquerading from the outside untrusted wild internet. So we do a show command here of Nugget In. Our first term is to deny spoof. That's the name of the term. We are matching from, and we're matching a prefix list, a source prefix list, so it would be the source IP address field, basically, and it's called internal prefixes. Now, I'll show you how we would configure that in a second, but the action we're going to take, or then, is to log it and discard it. What are we going to do here with this internal prefixes? Well, what we're going to match in our prefix list is actually this inside network, 172.30.102.0. What we don't want to happen is this. We don't want packets coming inbound from the internet to be spoofing or masquerading as if they're actually sourced from our inside corporate LAN. Okay, we definitely want to block those on the outside. So we would create basically a prefix list called internal prefixes to represent all of the inside prefixes or networks that we have, okay? Because somebody can do a social engineering or reconnaissance attack by making some phone calls or dumpster diving or maybe getting inside of our network and doing some packet sniffing and find out our internal networks. And remember, if somebody's able to do this, they can basically kind of fill in the blanks. I mean, if they know that we're on the 102.0/24 network, well, most network admins are going to put .1 as the router, the inside router address, which is going to be, for most of these hosts, probably their default gateway. We'll also probably put, on .2, 3, 4, 5 static servers like DHCP servers or DNS servers. So it's easy for somebody to kind of spoof and guess and try to masquerade as an internal DHCP server or the default gateway at .1 or a DNS server or other file servers, right? So we really want to deny this. But let me show you how I would create a prefix list real quick. I would go and I would want to make sure that I'm in the Edit Policy Options area. And we're going to create or set a prefix list, and this is going to be called internal. And usually I would put it in all caps, right? Anything that I'm creating, but I'll just be consistent here and call this internal prefixes. That's what we saw over there. And then we want to make sure that we have, and we'll do a question mark here, possible completions, well, the actually address prefix. So we're going to say 172.30.102.0/24, right? And that would create our prefix list. So with the prefix list called internal prefixes created, we can then access it here with this from statement. Okay, so let's say we don't match this, right? We'll move down to the next term. The next term is called allow estab or allow established, right? So what are we matching against? Well, first of all, it has to be protocol TCP, and then what we're using here is very interesting. What we see here as TCP-established, this is a text synonym. So we've got a handful of text synonyms that we can do to represent, for example, in this case, an established or completed three-way handshake, right? SYN, SYNAC, ACK. Now, if you go up to Juniper and you just search for text synonyms, let me show you. You'll find some document like this one, okay? And you can see this is showing, stateless firewall filter match conditions. So this is a really good document. But if I scroll down here, and you can see we've already matched a prefix, okay? We've done a prefix list. Remember, we just did that. But if you come down here, we can see some bit field text synonyms, right? And so here it is, the TCP established. We use that bit field text synonym. We've got first fragment, IS fragment, TCP initial, which is the initial synchronization flag turned on, or SYN-ACK. You can see here that TCP established, the one that we used, is going to match a TCP packet other than the first packet of a connection. So this is a synonym for the acknowledgement, the ACK, or the RST, the reset. All right. Now notice this, and I mentioned this earlier. This condition doesn't implicitly check that we're looking at the protocol TCP. Right? That's one thing I mentioned. You have to kind of let it know that. So that's exactly why our first statement was protocol TCP. Okay? You have to first mention the protocol and then mention this particular text synonym. Okay, so if we match TCP and established, we'll accept it. Okay? So we're going to go ahead and accept input established TCP connections. Okay, so this is kind of like in Cisco, we have what's called the established keyword. Okay, so if the session was initiated on the inside network here, and this is part of an existing connection, it's already been established, we're going to go ahead and allow that back through. Right? The third term, so let's suppose that neither one of these two match, because obviously accept is a terminating action, and by the way, this should be a semicolon here. This shouldn't be a container closure. So this should be a semicolon. Our third term is to allow ICMP. Okay, so if it's not spoofed and it's not an established TCP connection, it may be ICMP traffic. So if it matches from the protocol ICMP and it's of the ICMP type echo reply, time exceeded, or destination unreachable, we'll go ahead and accept those three ICMP types. And of course, there's a deny at the end of this, right? If none of these three terms match, we know it's going to be a discard. It's going to discard the packet. So if it's some other ICMP message type, it'll be discarded, right? If it's not an established TCP section, it'll be discarded, okay? If it's not on this prefix list, it'll be discarded. So a couple of good examples there to kind of get a feel for the syntax of the firewall filter configuration. Okay, our real-world scenario for firewall filters is going to actually get into the area of what we call router hardening or device hardening. Really one of the first things you're going to do before you implement, let's say, a true full-blown firewall solution. So we're going to go to our routers in Nugget Lab, and you're going to want to reduce the attack surface against those routers. In other words, you want to control just what management protocols you want to be able to access these devices and from which IP addresses or subnets / management VLANs that you want these devices to be accessed from. Okay, so I need to get into configuration mode in the 2350, which I am, and I want to say edit firewall, okay, to get into that configuration mode. Now let's take a look here while I'm here just real quickly. Let's just do an edit family to see what are some of the family of things I can do. Okay, so I can obviously go in and say I want to edit the firewall family any or iNet, which is IP version 4, iNet 6. And on the exam, by the way, one of the things I want you to remember is that notice how it says protocol family IPv6 here. Okay, be careful for any kind of distractors on the questions where the answer is something like, instead of iNet 6, it's IPv6 or it's iNet v6, right? Be careful there. Or maybe something like iNet.6. Those are all some common distractors. When we're dealing with IPv6, whether it be a routing filter or a firewall filter, it's going to be the iNet 6 family. Okay, keep that in mind. And also multi-protocol label switching, which you'll be learning about later on in your Juniper studies. So we're going to, of course, be doing iNet family here, IPv6. So that's the firewall family we want to configure in. So let's exit back one level here. We want to edit the family iNet, and we're going to create a filter. And let's go ahead and call this protect-RTR. We're going to protect our router. And this is what we call the control plane of the router, or traffic that is destined to the router itself, either one of the interfaces on the router that's the management interface like GIGI 000.0, or for example, it could be the loopback address, which would be a pretty good approach, because that way if we're using the loopback address as our identifier, then it's really on all of the interfaces, isn't it? But let's go ahead and create this particular filter. So let's think about some of the protocols, just fundamental protocols that I'm going to be using here to manage this device. I might want to use the ICMP protocol. I might want to do secure shell. I might want to do telnet. Okay, that's a good one. I might want to control FTP traffic. You know, just some of the standards, right? So let's go ahead and do ICMP first. Make sure we're in the Edit Firewall Family iNet Filter Protect RTR. Yes, we are. So I'm going to set my first term, and this is needs to be a name. So we're going to say CTRL-ICMP. Okay, we want to control ICMP, and it's going to be from the protocol. And lots of options there. Okay, so you can see how I can basically narrow the attack surface by only allowing certain protocols, right? Because if there's not a match, if I say, let's say ICMP, Telnet, Secure Shell, FTP, and those are in this particular firewall filter, if there's not a match, then only those protocols are going to be allowed. So if I want to use any of these other protocols to access this router, they won't be allowed to access the router. So notice we have ICMP here, so let's go ahead and use that option, ICMP, and hit enter. Now let's go up and see if we can do a ICMP and do type. There's ICMP type. Okay, let's go right down there. So let's go ahead and use that. Let's say ICMP. because we might want to get more granular, right? We might want to allow everything ICMP to access this router. I might only want to do echo request. We'll do individual entries, echo request, and then we'll do echo reply. Okay, so we'll allow echo request, echo reply. We'll allow, how about time exceeded? That'll be a good one for our trace routes or our path pings. Time exceeded. And let's go ahead and do unreachable. That's another good one we want to have on the list. And that way it'll only allow those, and the other ones that can be used for vulnerabilities won't be allowed. Okay, well, so far so good. We've got the ICMP protocol. We have 4 ICMP types that we're going to be permitting, and then now we want to set a term where we're going to say, and it has to be obviously control ICMP, and we're going to say from a particular source address. Now, remember, you could create a prefix list first. You could create a prefix list as I showed you, and then you could access that prefix list. Or you could just set the source address and say 192.168.3. And I know it's that my management station and also my management interfaces are on the 192.168.3.0/24 network. So I could go ahead and say that entire subnetwork, right? But that's not really reducing the attack surface. Yes, we're reducing it down, but that's going to leave potentially 254 possible source addresses that could access this device. And that's okay if it's a management VLAN and you have good physical protection, but I would like to have you be much more granular. So maybe do some type of subnetwork, right? Maybe something a little bit more, like /27 or /29, a subnetwork within that 3.0 network. So you just have a handful of hosts. Or you could even be really specific in my case and say 3.10/32. And that's the actual management station that I'm actually coming from right now. Okay, so that would really be reducing the attack surface down to one management station. Now that's kind of an extreme, but in my environment here, that's obviously the way to go. Now, that's ICMP. How about Telnet? Because I use Telnet all the time, don't I, to access this. So let's go ahead and control our Telnet traffic. Okay, before I set up my Telnet filter, let's go to Poderosa here and make sure that we can actually Telnet that 2350. So here's J2350. We'll go ahead and double click, and there it is, and I can log on as root on the 2350. So I've obviously created a connection, and I'm being prompted for my Telnet root credentials, or anything that has the ability to log on with an authentication class and use Telnet. Okay, so that's a good sign. So let's go ahead and clear the screen a bit here, and we want to do a term. This is going to be control Telnet. So within this particular filter, let's set another term, the second term, which is set term control Telnet. So this would be, as we've seen so far, term 2. And it's going to be from protocol TCP on port. We could use the number, which is 23, or we could just say on port Telnet. Then we'll say I just remembered I forgot something. In the previous, I need to set something for well, I'll do that in a second. I forgot to do my then accept statement, okay, for my control ICMP, but I'll go ahead and do that here in a second. Let's go ahead and finish this one so we'll stay, consistent. Let's set the term control Telnet, and we'll say from the source address of 192.168.3, and let's do this. I know this management station is on 3.10, right? Let's mess it up, right? Let's say only from 3.100. Okay, let's say I put an extra 0 on there by accident. And we're going to see now, we know that we could already access it through Telnet. So we'll put the wrong address on here, and we'll see if I'm able to still access it through Telnet once we apply this, right? Now, I forgot to do this on the control ICMP, but I'll go ahead and do it here, and then I'll go back and add that to the ICMP. Set term control Telnet, and we need to say if it's successful, okay, then we'll accept it. And I forgot that on the control ICMP, but I can go ahead and add that right now. So we'll set the term on control ICMP, then accept. Now let's do a show. make sure we have them right. So here's control ICMP, which is the first term. So if it's from source address 3.10, we'll allow protocol ICMP, but only echo request, echo reply, time exceeded, and unreachable. Okay, and so then we have our second term, which is term control telnet, which is from source address, and here we see 3.100, which is the wrong address, okay? It should be 3.10, but I'm going to make sure that it's working properly, where it's allowing protocol telnet on the telnet port 23, then accept. And of course, we know that there's a implicit discard at the end. So if the traffic that is destined for ultimately our interface is not matching one of these terms, then it's going to discard the packet. And of course, discard is not the same as reject, because reject would actually send an ICMP error message, right? Okay, well now we need to go ahead and apply this. So let's go to the top and we'll edit interfaces. And this is interesting because normally you would be applying this to the loopback address, okay? Because the control plane traffic is destined to the loopback address. You've either got dynamic routing going to the loopback address, which is representing all the control plane traffic to this router, and you've got static routes to this, right? You've got peering with static routes, or your dynamic routing protocol, you've advertised the loopback address, which here in my case is 192.168.2.1 if you go back to the diagram. But for my example here, I'm going to go ahead and do it on the management interface. So I'm going to say gig E0, not O, but 000.0, because this is my management interface. So I'm actually limiting this to that particular interface. When you get into Nugget Lab, probably you're going to use the loopback interface, okay? And we'll set the family INET, and we'll set the filter of protect RTR. All right. So I got to put input or output. That's obviously very important. I totally spaced it on that. Obviously, I mentioned that several times. We apply our filters as an input filter or an output filter. So we're going to apply this as an input filter, and it's protect RTR. There we go. And let's commit that. Okay, let's go back to Poderosa now. Bring it up here. Now, if I open this up and I go and I try to access my 2320, which is the other router that it doesn't have any firewall filter on it, and specifically doesn't have any telnet filter on it, I can see that I can access that, and I can log in as, MJS, and I can put in my password, and I'm on the 2320. But if I go up here and I say File, and let's access the 2350 using telnet, we saw what happened with the 2320, right? It's going to try to immediately create a session to that router, 2350, and I got a failed to connect the port 23 of the host 3.4, which is the 2350. So I'm failing to connect to that port because of the firewall filter that's applied to that particular device. Now, one thing I could do is I realized, well, I messed up. So let's go back and take a look at our configuration. Let's exit out of here. Let's go top, edit, firewall, and do a show. We can see that we're looking through here. Okay, why is it not working? Why can I connect? Because I know that I should be able to connect. We go, oh, okay. So we've got the wrong source address in there. Bummer. Okay, so we need to go fix that, don't we? So let's edit family INET, filter, protect RTR, and we want to edit term control telnet, and we want to delete from source address 192.168.3.100/32. We want to set from source address 192.168.3.10/32, or subnetwork, whatever, however you want to do this. Okay, and then we can go show source address. There we go. So we've gotten rid of that 3.100 entry, and we can go to the top and we can commit. And now once our commit is complete, we should be able to go ahead and now access the 2350 through your whatever telnet client you're using, because it's being permitted here from 3.10. And let's go ahead and take a look. Poderosa, File 2350. There we go. All right. So now I can access MJS, get access, and now I can go ahead and manage my 2350 through the telnet session. Okay. All right. Well, in this nugget of the JNCIA series, we looked at firewall filters in a nutshell. We explored the syntax. We saw the similarities and differences with routing policy. A couple of excellent configuration examples where we can see the fundamental power of a firewall filter. Then finally, our lab, where we reduced the router attack surface to just 4 ICMP message types and telnet from one single management station to our management interface. I hope this CPT nugget has been informative for you. I want to thank you for viewing. We'll see you in the next nugget on class of service as we continue our deployment labs.